50 participants, 14 Asian countries, 2 finalists, but only one will prevail to be the Asian King of Damat. Hello Asia and hello world! This is your resident host Jerald, and today we are about to witness a great battle which will decide the victorious among the cream of the crops and be hailed as the King of Damat. Will the 500,000 US dollars be taken home by a Filipino or by a Singaporean again? Send us your thoughts using social media by incorporating the hashtag DamatCount in your posts and tweets. We will be reading all your messages later. There's only one question for you to answer. And you know what? I'd like to ask, are you ready, Asia? I can't hear you! Yeah, that's the spirit! I know you're all excited. So before I explain to you the mechanics, I will first run through with our objectives. The objective of this game is to promote mathematical consciousness, especially in calculus, among Asian countries in particular, and the community in general through the organizers' community outreach Damat competitions across nations, and to integrate the Filipino checkered board game of Dama into the teaching of mathematical concepts and skills. Sounds useful, right? Now, our mechanics is pretty much the same and pretty much simple from the typical checkered game which we often play during our free times. Let's watch this video.
Our game is to be played by 2 individuals. The board contains 64 alternating squares and 24 circular chips, which will be the main paraphernalia of this game. Moving a chip means sliding it diagonally in the forward direction only, except when taking an opponent's chip or if a Dama chip takes an opponent's chip. We will be employing the touch move rule. A player who touches the chip is required to move unless it is not possible to do so. After each move, the player has to record his or her move in a score sheet, and only one score sheet will be used by the 2 players, which will be recorded by outscoring committee through the live telecast. There are several functions indicated on the chips. This will be used in solving differentiation and integration problems later on. Each player is allotted 1 minute per move, including the recording of the move by the committee and the corresponding score in the score sheet. Players have to do mathematical computation whenever they capture an opponent's chip. The game will go on until all pieces belonging to a player have been eaten and the scores are computed. When taking an opponent's chip, the taker chip jumps over the taken chip and uses any of the given functions given that will be differentiated or integrated where the chips land. Since this is Damath involving calculus, instead of operators, white boxes contain a problem that consists of f prime of x, g prime of x, and even its integral counterpart. Take note that the capturing piece will serve as the f of x, while the captured piece will be the g of x. After solving for the derivative or integral, the coordinates of the square will serve as the x1 and y1 of the expression to be evaluated. The computed value will then be added to the player's total score. The game ends if the 20-minute game period has lapsed, the moves are repetitive, a player has no more chips to move, and an opponent's chip is cornered. The remaining chip or chips of the player are to be added to their respective scores. We then need to evaluate the functions of their squares, assuming g of x is equal to 1. The player with the greater accumulated total score wins the game.
Now that we have understood the mechanics, we will now get to know our finalists. From the left side, we have Mark Velasco from the Republic of the Philippines. He is hailed as a 20-time champion in various Damat competitions in the Philippines. He is currently taking up STEM degree from a distinguished research school in the Philippines, the De La Salle University, Manila. If ever he wins, he will be the 4th one to bag a gold medal for his country. The last time the winner came from the Philippines was 10 years ago. This is the reason why he is determined to win. Will he be able to get the title, or will another contender get it? From the right side, we have Kimm Gonzales of Singapore. a STEM student from the National University of Singapore. He has bagged around 100 medallions in the International Checkers competition. If ever he wins, his honor will add to the 3 consecutive winning streak of Singapore in the world of damat competitions. This is the reason why he is determined to win. Woo! This battle is bound to be very tough, for this is not your regular damat competition. The final rounds consist of differentiation and integration problems. So, are you now excited? I know you are very excited since I've started this video. So, without further ado, let the damat battle begin!
First up, Gonzales moves his X-cube chip forward to his right. Next, Velasco moves his X chip forward to his left. Now we see Gonzales moving his X-cube chip forward to the left, taking Velasco's X chip. Gonzales lands on the box with the operator flashed on the screen, with the coordinate 2, 2. His score upon evaluating is -6. Velasco retaliates by moving his square root of X chip forward to his right, taking Gonzales' X-cube chip. Velasco lands on the box with the operator flashed on the screen, with the coordinate -5, -5. His score upon evaluating is 2.76. Next up, Gonzales moves his X chip forward to his right. Here we see Velasco moving his square root of X chip forward to his right, taking Gonzales' X chip. Velasco lands on the box with the operator flashed on the screen, with the coordinate 3, 3. The points to be added upon evaluation is -10.27. His new score is now -7.51. Next, Gonzales moves his 3x squared plus x plus 1 chip forward to his left, taking Velasco's square root of x chip. Gonzales lands on the box with the operator shown on the screen. Upon evaluation, the number of points to be added to his score is 519.45. His new score is now 513.45. Velasco then moves his -x squared chip to his right. Now Gonzales moves his 3x squared plus x plus 1 chip forward to his right, taking Velasco's -x squared chip. Now Gonzales lands on the box with the operators flashed on the screen, with the coordinate 4, 2. Upon evaluation, the number of points to be added to his score is 6. His new score is now 519.45. Now, Velasco moves his 1/x chip forward to his left, taking Gonzales' 3x squared plus x plus 1 chip. Now Velasco lands on the box with the operators flashed on the screen, with the coordinates 3, 3. Upon evaluation, the number of points to be added to his score is -5.67. Now, Gonzales moves his 1 chip forward to the right. Next, Velasco moves his X-cube chip forward to his right. Next, Gonzales moves his 1 chip forward to his right, and his 1 chip again backward to his right. In this, he takes the X-cube and 1/x chips of Velasco. Gonzales first lands with the box with the coordinates 4, 2, then to the box with the coordinates 2, 4. Upon evaluation, the number of points to be added to his score is 0. Next, Velasco moves his 1 chip forward to his right. Next, Gonzales moves his 1 chip forward to his right, taking Velasco's 1 chip. Gonzales lands on the box with the operator flashed on the screen, with the coordinate 0, 2. Upon evaluation, the number of points to be added to his score is 0. Next, Velasco moves his e⁻x chip forward to his right. Next, Gonzales moves his -x squared chip forward to his right. Then, Velasco moves his 3x squared plus x plus 1 chip forward to his left. Gonzales then moves his -x squared chip forward to his right. Here we have Velasco moving his 3x squared plus x plus 1 chip forward to his left, taking Gonzales' -x squared chip. Velasco lands on a box with the operator shown on screen, with coordinates 0, 4. Upon evaluation, the number of points to be added to his score is -1000. Gonzales then moves his 1 over x chip forward to his right. Then Velasco moves his 3x squared plus x plus 1 chip forward to his right, taking Gonzales' 1 over x chip. Velasco then lands on a box with the operator shown on the screen. Upon evaluation, the number of points to be added to his score is 0.83. His new score is now negative 6.68. Gonzales then moved his x sub 1 raised to x chip forward to his left, taking Velasco's 3x squared plus x plus 1 chip. Gonzales then lands on a box with the operators flashed on the screen, with the coordinates 3, 5. Upon evaluation, the number of points to be added to his score is 1000. His new score is now 1519.45. Velasco then moved his cube root of x chip forward to his left. Next, Gonzales moved his square root of x chip forward to his left. Next, Velasco moved his e raised to x chip forward to his right. And then, Gonzales moved his e raised to x chip forward to his right. Velasco moved his e raised to x chip forward to his right. Gonzales then moved his cosine x pi over 4 forward to his left. Then Velasco moved his absolute value of x chip forward to his left. Gonzales then moved his 1 chip forward to his left, taking Velasco's absolute value of x chip. Then moved backward to his left, taking Velasco's cube root of x. And finally moving backward to his right, taking Velasco's e raised to x chip. Gonzales first landed on the box with the operator shown and the coordinate 2, 0. Then he landed on the box with the operator shown with the coordinate 4, 2. Finally, he landed on the box with the operator shown with the coordinate 2, 4. The total number of points to be added to his score is 0. Velasco then moves his x sub 1 raised to x chip forward to his left. Next, Gonzales moved his 1 chip forward to his left. And then Velasco moved his x sub 1 raised to x chip forward to his right. Gonzales then moved his 1 chip forward to his left. Velasco then moved his x sub 1 raised to x chip forward to his left. Gonzales then moved his 1 chip backward to his left, taking Velasco's x sub 1 raised to x chip. Gonzales landed on the box with the shown operator. Upon evaluating, the number of points to be added to his score is 0. Velasco moves his cosine x pi over 4 chip forward to his left. Gonzales then moves his 1 chip forward to his left. Velasco then moves his cosine x pi over 4 chip forward to his left. Gonzales then moves his absolute value of x chip forward to his right. Velasco moves his cosine x pi over 4 chip forward to his right. Gonzales finishes the game by moving his square root of x chip forward to his right, taking Velasco's cosine x pi over 4 chip. Gonzales lands on the box with the shown operator with the coordinate 5, 5. Upon evaluating, the number of points to be added to his score is negative 1.41. Gonzales' final score is 1518.04. Meanwhile, Velasco's final score is negative 6.68. The winner of this match is Kimm Gonzales. This concludes the Damath competition.